made everything that is connected by wire with the same color. I bet that is crap on this monitor, isn't it? Okay. Now, a bunch of people, wait, battery and resistor? Or 4 resistors. Need to be more precise than that person. Okay. Now, most of the people told me an answer. I want you to identify what are the colors shared by your proposal. There should be 2. What pair of colors does your proposal share? If you can't see because crappy projectors, this is a green wire, this is the yellow wire, this is the red wire, don't cut it. This is the black one. All right. And tell me, your proposal should have 2 colors that both touch. Tell me what colors those are. Or maybe you realize that your answer was incorrect. You're allowed to change your answer to E. Please, I just asked you to tell me a pair of colors that both components share. I've got people telling me a color. How many things in a pair, people? I'm not Richard Dixon here. 2. You cannot share one thing, a pair of one thing. Both ends must have the same both colors. There have to be 2. Again, if you realize that you have a better answer for the D, you're allowed to tell me the 2 components that are actually in parallel. Oh, people are realizing their mistake. Oh, I'm so happy. 2 people got this correct in the 3 o'clock section with guidance. I'm pleased to see that we've got a dozen people correct. Okay, let's discuss this. One proposal is that black and orange are shared by B and D. Let's look at B and D. What pair of colors does B have? Black and orange. What pair of colors does D have? Black and red. Is that the same pair? B and D are not in parallel. Another proposal is that black and yellow are shared by B and D. What color does B have? Black and yellow. What color does D have? Not black and yellow. They're not in parallel. Another proposal is yellow and red. Yellow and red is proposed to be B and D. All right. What color does B and D have? Not yellow and red. B and C are not in parallel. Red and black. Red and black is proposed to be the answer to, no, they changed it. Okay. Okay. The correct answer is there are no 2 components which share the same pair. What can you conclude about the parallelitudinousification? There are no parallel components. A, green yellow. There's no other green yellow. B, black yellow. There's no other black yellow. C, red yellow. There's no other red yellow. D, red black. No other red black. Nothing is in parallel. Yeah. Are series in parallel opposites? No. If they are not in parallel, that does not imply that they are in series. Follow-up question. List 2 components which are in series for G. I will tell you that these are not all in parallel. They are not, none of them are in parallel. There is no parallel pair here. Pair parallel. The follow-up is there is at least one series pair. So tell me 2 things which are in series. Yeah. I told you could change your answer to E, but F should still be, no. Put this in F, put the G, put this in G. What I was looking for, what I was hoping to get is E, is people to realize the answer is none. And F is an A or whatever. D and E. Okay, so G, please, G, I want you to tell me two things which are in series. Okay, people are getting this. Good. So far, 100%. No, one bomb. Somebody broke 100%. Couple people broke 100%. Womp womp. I will remind you that series means they share a color and nothing else shares that color. The color that they join at does not get shared anywhere else. They're monogamous. They're color nogamous. Monogamous? Monochromatic? Sure. No, that means something else. Okay, as very many people are getting, C, D are in series. They both share red. There ain't no other red here. Better dead than red, the circuit says. Another series combination is battery A. Battery and A touch with green. There ain't no other green in the circuit. No. There are no other series. Please note, why aren't A and C in series? B is also yellow. Things are in series if they share a color, and that color is not shared by anything else. Battery isn't a color. Black is a color, which is joining B, D, and battery. That's right. So B and D and battery all have one side shared, but they're not in parallel because all their tops are different. They're also, none of those are in series with each other because B, D, and battery all have the same color. This is breaking series. Okay. Recognizing series and parallel is huge. You must learn this trick before test. I mean, you don't have to do the color trick, but you must be able to recognize seriousness and parallelism for anything else to make sense. Last question, what is true about current and parallel? Let's write down our little table about properties of series and parallel. Series, parallel, current, voltage. What I was fishing for, what I was hoping for currents in parallel is that they add up. You've got branches. The total current entering the branches has got to be equal to the sum of the individual currents in the branches. What about voltages in parallel? Anyone just shout it out. Anyone or everyone. Voltages in parallel. What's always true about voltages in parallel? Same, that's right. Not just the same, identical. When I use the word identical, I mean something stronger than equal. Two resistors connected in series. If they have equal resistances, they'll have equal voltages. It's not the same, it's not the identical voltages. Voltages are equal, not identical. I believe that all people are equal. Whoa, that's a crazy thought. I believe that I am equal to you, sir. That does not mean that I think that we are the same person. Identicalness, for me, means they're the same person. Equality means that they are both people with equal rights, responsibilities, whatever. All people are equal. No two people are identical. Right? Identical. My father's son and my son's father are the same person. That's what I mean by identicalness. Okay, current in series, identical. Every electron that goes through component A has to go through the battery. Every electron that goes through the battery has to go through component A. They're the same electrons. They're the identical electron. and voltages in series add up to the total. Suppose C's got, I don't know, 3 volts across it and D's got 8 volts across it. 3 volts and 8 volts. What's the difference in voltage across B? Again, C has 3 volts, D has 8 volts. What's the voltage across B? The voltage change here is trace volts, and the voltage here is 8 volts. How many volts does B got? This is in what? What combination is this in? What's the principle of voltages in series? If this is 3 volts difference, this is 8 volts difference, what's the total voltage difference? 11 volts. This combination goes from yellow to black. 8 volts, sorry, 11 volts, yellow-black voltage difference. What's the voltage of B? 11 volts. What's the total voltage of B, C, and D? Trick question, it's not 22. It's the same 11 volts. Identical 11 volts. This is my father's son. This is my son's father. Voltage-wise, those don't add together. My son's father and my father's son aren't a total of 2 people. It's a total of the same person. So it's the same 11 volts. Battery minus whatever A is dropping must be 11 volts. That make sense? Kind of? Okay. Let's apply these principles to ammeters and voltmeters. To measure current, to measure voltage, we use a, you'll never believe this, it's called a voltmeter. To measure amps, maybe originally they called it an amp meter, now we call it an ammeter because we're lazy. I ain't got time to pronounce a P. Oh, with the teacher schedule, I've got barely time to take a P, let alone pronounce a P. Real fast, HIJK, put your predictions. You can reason through these. Our goal is to reason through these. Take a stab at it for yourself. Real fast. 1 minute. H and J, high or low. I and K, series or parallel. Here are the symbols, by the way. An ammeter is an A in a circle. A voltmeter is a V in a circle. This is being recorded. Let me double check that. Yeah. Okay, time's up. That's been a minute. Most people have answered. Here's how I reason through this. What is current? What does it mean? What does it tell you? What is whoosh current? It's a flow, right? We're measuring how the electricity is flowing. It's like wind, right? You want to measure how much wind is blowing through a region or gas flow rate in some chemistry experiment, right? You guys do a bunch of chemistry in most of your majors. You got gas or liquid flowing through glassware, right? Everyone does that? Most of you do that? How would you measure the liters per second flowing through a tube? Don't you have to have a meter in that tube? If you want to measure a current, your ammeter had better darn well feel that same current. The current has to go through the meter. Which combination, series or parallel, feels the same current? Currents are identical in series. So an ammeter is always connected in series. Which kind of connection feels the identical voltage? So before I answer questions H and J, sketch me a pair of meters. And here are the symbols. Sketch me a pair of meters that would measure the current through D and the voltage through D. Current through D and the voltage across D. You can't answer this in the Google form, I think. So do this on your paper. Then show your neighbor. Sketch the circuit real fast. We'll use this several times. How would you measure D's amperage? How would you measure D's voltage? Where could I put a meter to be in series with D? Where could I put a meter to be in parallel with D? Time's up. Show your neighbor. Here's one possible sketch. Here's how I parallel things. I connect the tops to the tops, the bottoms to the bottoms. Same top, same bottom. Here is a way to put things in series. Whatever current leaves D has to flow through the ammeter. Please note, current doesn't go through a voltmeter. If voltmeters pass current, that would change the levels of electricity everywhere. If this sucker draws more current, then this sucker is going to drop more voltage. All of a sudden, D isn't going to have the same amount of voltage. Make sense? If a voltmeter pulls current, it's going to disrupt the levels that it's trying to measure. What's the resistance of a voltmeter? Ideally, infinity. In practice, like 100 million ohms is doable with modern technology. You have a 100 mega ohm ohm meter. Okay, why must a voltmeter have very large resistance? Because if this sucker didn't oppose current flowing through it, then that would change the current and voltage levels everywhere. This sucker would be pushing more current to supply both of these. If this sucker pushed more current, then it would lose more voltage. There'd be less voltage across this. All of a sudden, you change what you're trying to measure. Tell me about an ammeter. What would happen if an ammeter has big resistance? If the ammeter had big resistance, would you have a flow through it? Ideally, an ammeter has zero resistance. If you blocked up the current here by having a big resistance, there would be no flow no more. Turn to your neighbor and explain why. Why should a voltmeter have high resistance and be in parallel? Why should an ammeter have low resistance and be in series? Before we go on, tell me why. Ask me why. Tell me what. Ask me why. Give me a follow-up question. I hunger for your question. A voltmeter needs high resistance. Because if it didn't have high resistance, say a voltmeter had low resistance, a wire here would short out D. Right? If you had zero resistance across the component, it shorts it out. Why would current flow through D like it flow through the wireless head? All of a sudden, you have no voltage across it. If you have any small resistance for a voltmeter, the more that's going to change the voltage it's trying to measure. V equals IR. For if we're modeling current, if we're talking about the resistance of a voltmeter, the resistance of an ammeter, we're trying to talk about them as if they are resistors. A voltmeter, if this were a resistor with a different, with a finite resistance, is going to draw current. When current flows through this, that's going to change all the other current levels in the circuit. You're not going to measure what you want to. Okay, This is a 4-resistor circuit. Let's simplify it to a 2-resistor circuit real fast. Let's talk about what happens if you come up wrong. What do you think this ammeter would read? Question L. What do you think this voltmeter would read? Question M. We will reason why, but I want to get a prediction first. Everyone must answer a prediction. Please don't leave this blank or I'll assume you're asleep. You don't have to get it right, but you have to engage. I know you might think you're too young to get engaged, but I want you to get engaged. Class. Now that would be a polycule if you all got engaged with the class. I said get engaged with the class. I said, no, I want you to engage. Oh. Those are different. I was thinking. Okay, I've got people telling me high and low. I've got people telling me current and voltage. I want a number. Predict the number of amps that this ammeter would read. I want to predict it for the number of volts that will appear on voltmeter. My controls go. Darn it, blast it. Where am I? There. Okay, 10 seconds. And then I want everyone to make at least a prediction. Hey, also, people are still not distinguishing between voltage and current. When I ask for a number, henceforth, I also ask for a ratio. So I'm asking for a number with units, I want you to put units. Telling me 0 is not a correct answer. I want it to be 0 volts or 0 amps. Telling me 5 and 5 volts and 5 amps and 5 ohms. Always put the unit, henceforth. And I want you to think about it, practice it, and hopefully get it right more. So if you just gave me a number, tell me the number and the unit real fast. Okay, let's talk through it. Let's reason about it. An ammeter has 0 or infinity ohms. If this guy has 0 ohms resistance, is there going to be a voltage difference across it? If we model this as a resistor and say he's got basically 0 ohms, V equals IR, I times 0 is 0. What does that mean? The voltage here must be the same voltage as the voltage here. If the voltage across this 10 ohm resistor is 0, right? Voltages in parallel or identical. If this resistor has no voltage, will any current flow through him? No. You're shorting out the resistor. This resistor is no longer part of the circuit. He's got a short circuit around him. All the electricity would prefer to flow through the ammeter. This is why you were warned in lab 1, if you're in the lab section, this is why you were warned never to connect an ammeter directly to a battery. You connect an ammeter directly to a battery, it's going to suck as much current as the battery can provide. Batteries are designed to provide large currents. You're going to blow the fuse in the meter. Don't do that. Never connect a battery directly to an ammeter. Here, there's some safety. There's still 10 ohms in series with this meter. What's the voltage difference from here to here? What do we define the voltage at the negative terminal of the battery to be? 0. What's the voltage here? What's the voltage here? Okay, I think people are spaced out or something. Put it in the Google form. Okay, I'm going to guide you through. Here's how I reason about it. I want you to be able to reason through the answer. Don't memorize these things. An ammeter is a short circuit. An ammeter is a 0 ohm resistor. An ammeter pulls as much current as can be provided. If there's a 0 ohm resistor here, all the current will flow through here that can. No current will flow through here. 0 ohms can have no voltage difference across it. That's the meaning of V equals IR. Voltage across a component, the resistor, equals the current through it times the resistance of it. If the resistance is 0, voltage will be 0. Voltage difference from here to here is 0. If there's no voltage difference, then if this is 0, this must also be. So what's the voltage drop that the 10 ohm experience? The top 10 ohm experiences. Put that in Google form N. What is the voltage across the 10 ohm, top 10 ohm resistor? How much voltage does this sucker feel? Question N, how much voltage in the top volt? If your answer is in amps, go to jail, go directly to jail. Do not pass go, do not collect 200 volts. If I'm asking for voltage, the answer should be in volts. The correct answer is 12 volts. If there's 0 volt difference across the ammeter, and this side is at 0 volts, that must mean this side is also at 0 volts. This side is at 0 volts. This side is at 12 volts. The difference between 12 and 0 is 12. This resistor feels 12 volts of voltage. How much current does a 10 ohm resistor pull when it's subjected to 12 volts? Again, 10 ohm resistor, 12 volts across it. What's its current? What's the equation that tells you current through a resistor? V equals IR. Apply V equals IR. V is 12, R is 10. What's I? Put it in the Google form. D, O. If you've got 12 volts and 10 ohms, how many amps have you got through that resistor? Apply the equation V equals I times R. V is 12, R is 10. Math carefully, please. If you answer in amps, then you get points. If you answer in volts, oh good. People are measuring amps and amps. What's an ampman? You crazy, man. Correct answer is 1.2 amps. V equals I times R. I equals V divided by R. Well, divided by 10 also goes by the name 1.2. Great, 1.2 amps. These 1.2 amps, where do they flow? Yeah, but where do these 1.2 amps end up? Through the ammeter. You got a 0 ohm resistance path. Yeah, you see that? You got a 10 in parallel with a 0. Everything's going to flow through the ammeter. So what's this going to read? 1.2 amps. Making sense? Okay. Follow up. If you were trying to measure the current in the circuit, what's the current when 12 amps flows through 20 ohms? You can bust out a calculator if you have to. This should be straightforward. V equals I times R. What's I if V is 12 and R is 20? 0.6. So do you notice how putting an ammeter in parallel has changed the original current that you might have been trying to measure, 0.6 amps, into 1.2 amps? Now you've got half as much resistance, right? You've shorted this out. Yes, no, maybe so? Yeah? Yeah? Okay. I have applied reasoning to discover that an ammeter can't be placed in parallel or it'll shift everything, change. What if you're trying to measure the voltage across the 10 ohm this resistor by putting him in series with the resistor? Find the voltage that this voltmeter would register. Apply the same reasoning, except for volts instead of current, volts instead of amps. For series instead of parallel. What must this show? Discuss with your neighbor real fast. This is hard, but you can do it. You can think through this. Put your guess in P. Put your revised guess in P. And let me know when I can continue. Everyone answer in P. When you've reasoned about it. What is the voltmeter going to register? Here's M, a second shot at M. Again, I'm asking for the voltage that the circuit would measure. If you answer in amps, then I'm going to send physics police to your house. I'm going to beat you with their volt baton or kilogram baton. I don't know. That actually sounds like girl things. I'm trying to be silly. No, I'm trying to make it silly, not threatening. Give you another hint. There is such a thing as a circuit which boosts voltage. We're not going to get there. You've got a supply that is boosting electricity to 12 volts total voltage. Are you going to get 120 volts out anywhere in the circuit? Only got a maximum of 12 joules per each coulomb of electricity. Each electron has a maximum of 12 divided by a big number of joules. So you can't have 120 volts in a circuit that's only got a 12 volt battery. That you know, so that we will come. There are advanced things that can be not. Okay, let me walk you through this so you can understand this. First off, by the way, if I'm trying to measure the voltage of a 10 ohm resistor and series with a 10 ohm resistor, what would the voltage be? 12 volt battery connected to two 10 ohm resistors. If I want just the voltage across one of those resistors, what should it be? I want to try that. Should it be? What's the principle of voltages in series that I wrote down at the beginning? Voltages in series, what? Add to the total, that's right. Two identical resistors have voltages that add to the total. What should their individual voltages be? 6 and 6 volts, that's right. So this should, if I were measuring the voltage across this correctly, it should say 6 volts. Now let's reason and see what this voltmeter actually reads. Does any current flow through the voltmeter? No, why not? Effectively infinite resistance. Does any current flow through this resistor? This is in series. What's true about currents in series? They're identical. So if 0 amps flow through here, how much current flows through here? How much current flows through here? How much current flows through here? If they're in series and one component blocks up the works, you're not going to have a flow in the other components. Does that make sense? Okay. So if this sucker blocks up the works, can it feel voltage? Yes. Here's why. What does volts equals amps times ohms tell you? What volts? The change in volts across the resistor. No amps here, right? We just reasoned there's a blockage. You can't flow current through here because he blocks up the works. So how many amps? So how many volts? If this point is at 12, what's at this point? What did we just say the voltage in V equals I represents? It's the change in volts. If this point's at 12 and this point's at 0, is there a change? Yes. What must this point be at if the change in volts is the V equals I equals 0 is 0 here? 12. Again, reason through this. I is 0 block. V equals IR says the voltage change in this resistor is 0. How do you keep from changing the voltage? If change is 0, you're at the same level. This is 12, that's 12. Duh. I see a lot of stunned faces. Reasoning. Step uno. No current because infinite resistance blocks it up. Step dos. V equals IR says no voltage across the resistors. No voltage what? No voltage change. No voltage is lost in these resistors. No voltage is dropped. So if this is 12 and this doesn't change, what's this? What's this? What's this? 0. This is the negative terminal of the battery. This has a big resistance, so you can change the voltage. He's blocking up everything. All of the pressure differences across the question. How much is the current in the circuit? No. Yes. Why? What's the resistance of a voltmeter? How much current flows through an infinity ohm resistor? V equals IR. Infinity times what? 0. Current in a current through a voltmeter is 0. Current anywhere in the series circuit is 0. Yeah. If there's no current, how much voltage is lost? How much voltage is lost? V equals IR tells you change in voltage through a resistor. If there's no current, there's no change. Follow up reasoning. I've walked you 99 steps. You take the hundredth. Question Q. What does the voltmeter measure again? If there's no change in voltage through those resistors, I'll take your question. 2 shakes of a lamb's tail. What's the voltage that the meter registers? This is 99 steps. You've got 99 steps, not 99 problems now. The voltmeter is one. I've actually heard that song. One more time, the hints leading up to it. Voltmeter has infinite ohms, therefore he blocks up all current, therefore no current anywhere because series current is identical. No current means no voltage is lost in a resistor. If it's got 0 current and 10 ohms, the voltage on either side has to be the same. This point is how many volts? If the voltage doesn't change, this point is how many volts? Which means the voltage here is how many volts? This is the negative terminal of the battery. What's the voltage of the negative terminal of the battery? What's this voltmeter saying? What was your answer for Q? 12. Hey, turn to your neighbor and explain the chain of reasoning. Oh, lots of correct answers when I guided you through. Good. When I say drop,
Oh,
if the voltage decreases,
already.
what is the drop in height from here to here? Is it -1 meter?
No.
What is the drop in my bank account when I go to Starbucks? No, the drop is a positive number. I decrease, so my drop is positive. So my drop is negative. The balance, if I subtract the drop, my balance is drop. Subtracting an increase. My bank account drops a negative number when I get paid. Negative right is left. Negative drop would be an addition. If you can reason through this, you have learned something about the nature of V equals IR series and parallel voltage current. But we've been doing this for 3 weeks. Your college students, I expect a lot out of you. Also, you've got the best professor in the world. So I do expect that this should be hard, but that you should be here. Ask me a question. Yeah.
So if there's no current through it, how can there be a voltage when the voltage is joules over charge?
So if the resistor has a voltage across it, that means joules for the charge flow through it are being lost. If there's voltage difference from one side to another, joules are being lost. There's no voltage change here. No energy is lost. There's no flow. There's no voltage change here. There's no energy loss. There's no flow. So if you start with 12 volts and don't decrease any and don't decrease any, how many are left?
Then it would start, but if there's nothing to begin with because there's no current, how can
Nothing what? No what?
no.
You said there's nothing to begin with. What are you talking about? Voltage, current, resistance?
Well, if there's no current, then mathematically there's nothing to divide joules by, which is the defining thing for voltage. So there wouldn't be a voltage in the first place. Can't divide
If
it by zero.
there are no volts, you can have a joules divided by coulombs gives you 0. Joules are 0. Joules lost in that component are 0. What does V equals IR tell you? V equals IR doesn't tell you the joules in the electricity in that resistor. It tells you the change in energy as the electricity passes, or in this case, there's no flow at all. There is no passing. There is no motion through, no velocity in there. The electrical energy level here, the electrical energy level here are the same because there's nothing being lost for this resistor.
So there is charge in the system.
Yes.
It's not a change charge.
The word charge is technically true, but I think you're talking about energy. Charge is not energy.
Well, no, I am talking about charge. You said that the amps is 0,
That's true.
but if there's no amps, no coulombs, then there's nothing to divide joules by to get your value for voltage.
Ah, you're talking about the denominator. There are always coulombs. What current is not joules per coulomb. What volts are not joules per voltage in V equals. Charge is not 0. There's charge everywhere. There's always free charge. You got metal, you got charges. How much energy are those charges given? This battery boosts, pressurizes the the electricity in this wire to 12 volts. What's the voltage if you just hold up a battery? What's the voltage of the positive terminal? It's not connected to anything. But the voltage at that terminal is still 9 volts, 1.5 volts, whatever the battery voltage. It's not driving charge anywhere, but it still is pressurizing the metal of that positive terminal. Even if that charge is not flowing anywhere.
But in order for the voltmeter to register that, wouldn't it have to have going through it? Wouldn't it have to
Nope.
have an outlet to read the voltmeter?
The voltmeter registers the difference in electrical energy, the difference in electrical pressure present at this place versus that place. This place, negative terminal of the battery, it feels no electrical pressure. This place feels the full battery pressure right? Because no energy is being lost because no charge is flowing through those wires, through those resistors. Think about it and ask me a follow-up. Yes, Mark.
So if we got rid of one or both the resistors with the,
Nothing would change. If you replace those with 0 ohm resistors and 0 ohm resistors, still got infinity ohms, still got no current, no resistance. You're just no resistance here. You're just connected directly to the battery. Try it in lab. Hook up the voltmeter in series with some battery. There is battery one. Yeah.
what happened if we had components in parallel, like we one past the place of the street?
You mean a voltmeter connected in parallel with this here?
Like,
6 volts. That's the correct way to connect it.
I meant, like, so if we added a wire panel past the first resistor,
With a voltmeter or an ammeter? Or just a wire?
just a wire.
If I short from here to here with a wire,
So add
there'd be no change.
add the wire past the first resistor, and then go down and add another resistor, and then connect it to the last app.
Another resistor here,
No.
another wire here,
Go, put your
another wire or resistor here.
Put your hand to the left, go up, right a little bit, go down, add a resistor, and then connect to the final path.
Let's do that. What do you think? What do you predict? Take a second. It's a great follow-up question. Question R. Attempt to analyze the voltage of this circuit. Now I've got a path through which electricity can flow. Hey, now there's current flow places. What do you think? Oh, take a second. Take a second. This should take a little bit of time. The follow-up question, what? R is, I'm still asking what the voltmeter would register in this modified circuit where I do have a path through which this flow. Great follow-up. Does everyone see the question? Does everyone see the modification? Analyze this sucker. You can do it. Now there's flow. What does that change? Talk to your neighbor. Again, you won't get more out than you put in with the battery. Cannot get 120 volts out. Again, no current will flow through this rightmost resistor, but current will still flow through these two resistors. How much current will flow when 12 volts is across 20 ohms of resistance? We just did this. 0.6 amps? Okay, so there's 0.6 amps flowing here, 0.6 amps flowing here, the same 0.6 amps, not a total of 1.2. This 0.6 amps is this 0.6 amps, is that 0.6 amps. How many amps are flowing here? 0. He's in series with an infinity ohm. I start at 12 volts here. 0.6 amps flow through 10 ohms. What does that do? Giving you all the steps except for the last one. 0.6 amps flow through the top resistor and the middle. 0.6 amps flow through that top resistor. What does the voltmeter measure? Correct. Start at 12. Drop by 0.6 times 10, you're at 6 volts up. 6 volts across this resistor is going to drive how many ohms? Amps? 0.6 again. But still, this level's at how many volts? And this level's at How much current is flowing through this sucker? 0, right? So this level's at 6, there's 0 current flowing through here. What's this level? 0 volts across a resistor means it doesn't change the voltage. There's no energy loss because there's no current flow. If this point is at 6 volts and this voltage across this resistor is 0, that means that this point has to be the same as this point voltage-wise. The voltmeter would read 6 and the spot finds it. No, you guys don't like that at all. Marco?
Is it? So like for the resistor, like behind the voltmeter, if they're.
This one?
No, the one,
This one?
yeah, if that had a higher resistance, would that change it at all?
No,
Or still-
no change.
Okay,
If there's no current through it, there's no voltage drop across it, no voltage drop across it, it's top and bottom at the same level. It might as well be a wire. There's no voltage loss there, it might as well be a wire. So what's the color along a wire? The same color, yeah? If this is just a wire, no voltage loss, and this wire color and this wire color are the same. Say this level is yellow and this level is black. What level is this? Yellow. If there's no change in voltage, effectively, he's a wire, effectively, you can color the whole damn thing with yellow.
If there's no change in voltage for the right resistor, why does there seem to be, from my understanding, a change in the top voltage?
There is a change in voltage across here because there's a current through it. Now,
Oh,
there's a conducting path. Now you got a circuit. Path through its working through both.
so because we know that the rightmost one has 0 voltage, there's not going to be any change because of that?
Right one has 0 volts because no current can flow through him, rock up there. If there's no voltage across the resistor, that means voltage stop changing. No change in voltage means that this level has to be the same as that. Yeah. One more follow-up question. You want to ask again? Anyone? Yeah, in the back. Sure. Wait, let me be precise. The flow of electrons and flow of current. The current can't bunch up. So suppose this was a highway system. Here's the 60. You know the highways in town? Wait, let's talk about West Valley. Because you probably, do you live in the West Valley or East Valley? West Valley? Okay, so here's the 10, here's the 17, here's the, what is that, the 202? Suppose we put a police blockade along the 202. No current can flow here. Cars are gonna back up. There's gonna be no traffic. Oh, there's gonna be a lot of traffic. There's not gonna be any flow. Wait, say that again?
What happens? Or it does not matter?
Here?
Yeah.
What do you mean by the voltage being in front? Oh, do you mean what happens if I switch the voltmeter to the resistor? No change. If there's no voltage being lost here, the voltage on either side is the same. The voltage side is the same means it's basically a wire. This voltmeter is connected effectively in parallel with this resistor. If this is a wire, who cares about it? It's just, its resistance doesn't do anything. So it doesn't lose energy. So however much energy is here is also present here. Per voltage of the meter will be identical to the voltage across this resistor, yeah. Okay, suppose I change the values around. And this guy gets 20 volts, but that can't happen. This guy gets 8 volts. Finish things up. Suppose this guy drops 8 volts. The resistor values are different. This guy drops 8 volts. What does this guy get to measure? 4 volts. He blocks up the current. This current doesn't lose any voltage in this resistor. This voltage at the bottom and the top are the same. Voltage at the bottom and the top are the same. If I start with 12 and I lost, there's 8. If I lost 8, there's 4 volts left for this point. There's 4 volts left at this point. If and you are struggling with this, I suspect problem is in either two places, series and parallel concepts, which is to say this little table. This little table makes sense to you, then please review the meaning of V equals IR. So I've been actually saying shorthand. It's not actually all wait 2 seconds. There's one last equation to give. The meaning of V equals IR is actually the delta V across the resistor. Delta V, the change in volts. It's not the voltage at the resistor. It's how does V change from one side to the other. What? What I actually presented in lecture, I've just been abusing terminology. It's not voltage equals current times resistance. It's a delta V, change in volts across the resistor. Okay, the last thing, I would have liked to have derived this. Series assembly, just add up the resistance. We did that in lab week 1. If you worked real fast and you maybe got in week 1 through the second part of the lab, I'm not counting on that. That was a lot of things to learn at the beginning. If you've got parallel resistors, you can replace parallel bunches with a single value of the reciprocal of the sum of the reciprocals. We're going to apply this left, right, and center tomorrow and in the homework. And tomorrow class, Wednesday, will hopefully derive. Yeah. Just like last semester. Wait, were you in my class last semester? Okay. So what I do for the exam is every question is directly taken, gently modified, so you don't just memorize, but is taken from either homeworks or tests, homeworks or quizzes or in-class examples. You will have seen every situation. Now I might change it slightly. If on a quiz I ask, what is true about voltages in series? I might ask instead, what is true about currents in series? You know, I don't want memorization to be a strategy. But all of it's important. If you've got time, do you want me to run through the quiz?
Yes, I got it.
I can leave this on the recording. I'm going to leave this recording. If you don't have time, get out of, or mental, emotional energy, get out of here. I will go ahead and answer the quiz real fast. So if you got to go, just look at the recording afterwards. Yeah. Okay. Let's hit the quiz real fast. Where did? Come on, where's the freaking? There. Come on. You have a good question, Wallace?
Possibly the second one, so close to this one, so I'm maybe possibly just adding this name.
Subtraction off of that.
Like when it's really measuring this one, since this doesn't mean anything, like I said, it's just a number.
So we're measuring how much voltage this is lost out of that.
So like,
How much voltage is left, I should say. Yeah.
because like
It's not the voltage process.
Just how much is left after this. It's
Uh-huh.
losing here, and then like, so this is just a wire.
There's no loss.
So it's just whatever is getting charged through here.
Voltage, you say. Yeah, that's right. If you got further follow-ups, I do want to answer the quiz for the recording. Office hours 10:30 on Wednesday. Can you make?
Yeah. probably.
Come.
You said in the beginning, it's the identical electron.
For current in series, yeah.
Is it actually the identical
Mhm.
electron? Fine.
Depends on how long you let the circuit run. Just for a little, the electrons drifting in this wire and the electrons drifting in that wire. But if I touch opposite prongs in an AC circuit, the electricity that kills me was the electricity inside me all along, just like a Disney movie. But if you have a battery,
Existing state.
if you have a low resistance, current will flow through you.
Yeah.
Current flowing through, if it's big enough voltage, current flowing through your heart will, the current flowing through your heart will confuse your pacemaker
Yeah,
cells.
that's true. I was thinking more like burns, I guess.
What kills you is not burns.
Yeah.
Well, depends on what the bird is. If you're in a power plant, you touch a 450,000 volt wire here and 0 volt wire there, yeah, you're gonna have a very painful day. Yeah, anyway,
That's that. Two batteries.
what? Come on, what? Okay. For the recording and the 4 people who could stay here, let's talk about this. To reason through this, you need Kirchhoff's current law, the idea that what goes in must come out of any point. I've got I2 approaching this point, I've got I3 exiting this point, but I don't know the current in this wire yet. I do know the current in this resistor. I1 amps flows through this resistor. How much current must exit this point? I1 amps, which direction? If I1 amps approaches this point, I1 amps must leave this point.
Into the positive.
Recharging this battery, presumably. How much current must exit the battery? Every amp that entered it. Current in series is identical. Current is not lost in series. Volts might be lost, but current's not lost.
Does battery 2 not add to the current at all? It doesn't push back, it doesn't.
It does push. So if you don't have this battery, if you replace this with a wire, everything would be different, yes. But if the battery's in series,
It doesn't.
what flows towards it must go through it.
So I1 is gonna be consistent, but if it was replaced with a wire, the value of I1
Would change, absolutely. Still, replace it with this wire, replace it with anything, any current that goes through this, whatever component this is gonna flow through this, unless you replace it with an open circuit. If you replace this with a voltmeter, if you replace this with a voltmeter, you could say that the current through it is 0, therefore this current is 0. You could actually still say that this current will become 0, and still say 0 amps flows through it. Anyway, every amp that flows through this, every one of the I2 amps that flows through this will have to flow through this, will have to flow along this wire. So what currents exit must enter? What currents enter must exit? I've got I1 and I've got I2 entering. I've got I3 exiting. I1 plus I2 equals I3. Bang. You gotta pick a point, any point. What happens if I pick this point? I know I1 and I2 are exiting it. How much current is in this wire? I don't know. But I can reason if I know I3 down here, every amp that flows through here must also flow through here, must also flow through here. I3 amps are flowing there.
So that's like I3 equals I1 plus I2.
I'm so close, I'm just answering like, I will be home. I am finishing a video, I'll be back. Love you. Okay. The correct answer, I3 equals I1 plus I2. Battery.
To go back to question one.
Sure.
I understand, but
Good.
let's say
Well, if, let's say if it was I4 at the bottom, would it still be like, no, that last resistor? Yes, exactly. So are we going off by that resistor to determine the rest? Like the flow of it?
Say more.
So I3 equals I1 plus I2, right?
Mhm.
But so are we always looking at that resistor at the bottom to determine the,
Pick any point in the circuit. Any point where wires meet. Any currents approaching that point must be balanced by currents exiting that point. It's not about this resistor. It's about this point and the three places that connect to it. Or about this point, equivalent. You get the same answer regardless of the node you analyze.
Are batteries resistors?
No,
Uh,
resistors have a voltage across them that depends on their current. Batteries have a voltage across them that depends on their
so.
chemistry.
So. As the current is flowing into this battery and out of it. It's not changing the resistance between those 2 points, I guess you could say.
The resistance of the voltage.
The voltage, I guess,
The
but
voltage absolutely will be different from here to here. This battery maintains a voltage difference across its terminals. This is a 12-volt battery. Whatever voltage is here, this is gonna suck 12-volt out.
got you.
The voltage here
Even
will
if the
be,
other battery's like 9 volts? Or
if this volt battery is a
It's gotta
9-volt
be
battery, I don't know, they have voltages in the currents everywhere, but I do know that whatever voltage is here, this is gonna be 9 volts greater than it. That's what the battery does. Its positive terminal will be that many volts higher than its negative terminal. Its negative terminal will be that many volts lower than its positive terminal. You know the voltage at one side of the battery, the voltage at the other side is,
so when you go to recharge and remake this gradient, it doesn't get harder to,
it will get harder as you change the circuit. But if I've got a 12-volt battery here, I can find the voltage difference here. If I got a 9-volt battery here, whatever, if an X-volt battery here, I know that the voltage here compared to there will be X volts higher. Best, but I want to move on. My wife will come. There are a couple of ways to do this. I saw two challenges for the people who asked about this in office hours. One was interpreting the mathematical meaning of the statement, well, fraction, the total, was the 3 ohm resistor. To do this straightforward way, you find a mathematical expression for this I, find a mathematical expression for this I, divide. This divided by this is what I mean by fraction of the total in the 3.
can write it out algebraically.
I3 divided by I,
I3 divided by,
if I3 or IA.
so 3 times. 3 over 1.
You can't have more current through this than is entering.
I3.
No. I subscript 3. I subscript A. The current in this resistor,
Okay,
not 3 times I
Got
divided
you.
by.
I,
Okay. Straightforward, intuitive way to do this is to say, these guys have the same voltage, right? They're parallel.
here, yeah.
Parallel voltage is always identical. This guy has a third the resistance of this guy. Parallel, same voltage. Resistance ratio is 1 to 3. Current ratio must be 3 to 1. Right? If R is 3 times greater here, then I must be 1/3 as great as there.
Yeah.
So far so good. To multiply up the same V. If this has 3 times the current as this, 3 units here, 1 unit there, how many total units? I don't know how much current is flowing here. I don't know how much current is flowing here. I know there's 3 times as much current flowing in here as there. 3/4 of the total is flowing here. 0.75 is the correct answer. Longer terminal, positive. Higher voltage, positive. Follow-up questions, especially about the first and third. I think you're the hardest.
Yeah. It's the third.
Still squaring with you?
Yeah.
The fast, intuitive way to do this again, and you could rewatch the video. What the three logical steps? Parallel of voltage is the same. If V is the same, then I times R equals I times R. I of this times R of this equals I of this times R of this. R is bigger than this, I is bigger than this. By what ratio? Inverse ratio. 9:3 resistance ratio, or 3:1 resistance ratio, 3:1, 3:1 current ratio. You got 3 units here and 1 unit there. The total units are 4 units. This is 3 of those 4. This is 1 of those 4. 0.75 is the fraction of the total. My wife is going to kill me. Before I die, please remember me fondly, I hope. Yes, always. Monday, Wednesday, 10:30. What is the fraction of voltage across R2? How much voltage compared to the total voltage does R2 feel? This time, what is the same for both resistors?
The resistance.
Not necessarily.
The current.
The current in series current is always identical. So if I is the same, what is the ratio of the voltages? If they're equal, it's 50-50, but if they're in general, if I is the same, then voltage is directly proportional to resistance. Directly proportional means if this is a 5-to-2 ratio in resistance, it'll also be a 5-to-2 ratio in the voltage. If this is an 18 and this is a 27, if this is an 18 and this is a 6, that divides. If this is an 18 and this is a 29 ratio, then this will be 18 to whatever 18 plus 29 is, ratio of voltage. The short answer, and I encourage you to reason through this yourself, the voltage ratio of this 2 total is the same as R2 over R total. R2 over R1 plus R. Yeah. So far, equation wise, voltages add up. The voltage across each resistor is the current through that resistor, same number, times the resistance of that resistor. What I asked for is the voltage of 2 across the total voltage. Voltage of 2 is I times R2 over I times R1 plus I times R2. I cancels, you're left with R2 over R1 plus R2. R2's share of the voltage is R1's. R2 share of the voltage is R2 share of the resistance. This is called a voltage divider circuit, and it's actually practical. It's used in lots of places. Find a bit more asked later, but now, lest I die of white.